0, action. Good morning, class. This is Mr. Eggleston, and this is the Algebra 2 Spring Final Review that I'm going to do a few selected problems. There's a whole bunch of problems on this. I think the total number is like 40 plus. I'm not collecting this for a grade. You do not have to do anything on this. But if you want to know what's going to be on your final and you want some practice, you should attempt some of these. I supplied answers to some of the questions, or to all the questions, and I'm going to be doing the video for a select few, the ones I have circled. I have about 20 of them, so I'll probably break this up into 2 videos. All right, so let's begin. The first question is about a food truck that sells tuna fish sandwiches for $5. That's supposed to be $5.50. Like that. It kind of dropped the last 0. Each has a fixed cost and has a fixed cost of $3.50 per day. That could be rental space. It could be all sorts of stuff to operate. If the food truck sells an average of X sandwiches per day, write a rational function to represent the per sandwich profit. So first we have to figure out what profit would be. Profit, P as how do I say this? P as a function of X will equal your daily cost of $350. Actually, let me restate that. It will be how much money you make, which is $5.50 per sandwich. So it'll be $5.50 times the number of sandwiches you sell, minus the daily per day charge of $350. All right, that would be the profit. And if you want it per sandwich, that's going to be P of X divided by X, where X is the number of sandwiches. So it would be, this is the expression that you're supposed to write. 550X minus 350 over X. Now, if you look at this, just like this is a rational function, if we're looking for, what do they ask you for? Oh, this is just the function. So this is the function right here. This is your answer. Then they say, what is the per sandwich profit for a day when 120 tacos were sold? They're basically asking you for the P at 120 divided by 120. So that you just use your calculator, 550 times 120 minus 350 divided by 120. And using your calculator, and I'm going to use a hidden calculator, Desmos, on my computer so that I don't have to worry about it too much. Where is it? Right there. Okay, so let's go to that. And so I want to know what 5.50 times 120 minus 350, and that equals 310 divided by 120, which works out to $2.58 per sandwich. Per sandwich. That's how much profit you would get from each sale of the sandwiches. All right. Now on 3 and 4, they give you a pretty basic rational expression and function, and they want you to describe the transformations. Well, f of x for number 3 is a rational function that is reflected because of that negative sign in front of the 1 over x across the x-axis All right, and it's translated, shifted, if you will, down 1 unit. And that's it. For number 5, very similar to number 3, except for there's also a horizontal translation. It would be it's F. F of x f of x is a rational function that is reflected, because of the negative sign in front of the fraction, reflected across the x-axis and shifted right 2, because it's a negative 2, and remember your x's are liars. So if it's x minus 2, it's right 2, not left 2, and down 1 because of the minus 1 here. Okay, there you go. Question number 7. Identify the following features of the rational function, the vertical asymptote. Notice the denominator is not just x plus a number or minus a number. It's actually 2x minus 4 is the denominator. So to find the vertical asymptote, we want to know for what values of x does that equal 0. Add 4 divided by 2, you get x equals 2. So the vertical asymptote's at x equals 2. Horizontal, again, is the number, if there is one, that's added or subtracted at the back end. And that's going to be y equals -9. Notice, I'm writing equations of lines. All right, the domain is going to be all reals, except x cannot equal 2, because that's a vertical asymptote. And the range is going to be y is greater than, forgive me for saying that. That is wrong. The range is going to be all reals that's y is greater than -9. Okay, that was number 7. Now, identify the holes, vertical asymptotes, x-intercepts, horizontal asymptotes, and domain of each. So, vertical asymptote, okay, holes, the VA, the HA, well, actually, they have x-intercepts in between, x-intercepts, and domain. Okay, holes. Well, we factor everything that can be factored, so we can see this. And this one, really, the only thing that can come out of the bottom is a -4 because of the, that's the only thing common, and it's x minus 4. So are there any holes in this graph? No, because there's no holes. Because there's no common term on top and bottom that can be divided out. What's the vertical asymptote? Well, the vertical asymptote is when the bottom is equal to 0, so that would be when x minus 4 equals to 0, which means x equals 4. What's the horizontal asymptote? Easiest to look at the unfactored form right there and do the ratio of that, because that's when x gets big, and y equals 1 over -4, which is just -1/4. And the x-intercept is when the top is equal to 0. So the x-intercept is going to be at x plus 4 equal to 0, which is x equals -4. And the domain is all real numbers, except x cannot equal any holes, locations, or the vertical asymptote. So x cannot equal 4. All right. Now, looking at number 9, same idea, holes. They want vertical asymptote. They want horizontal asymptote. They want the x-intercept. And they want the domain. Well, this one's a little bit uglier. You're going to have to factor everything that can be factored and see if things can divide out. So we got x plus 3 on top. Nothing you can do to that. You can factor out -4 on bottom, and that's x squared minus x. 24 divided by 4 is 6. So it would be -6. Okay. Keep looking at the bottom and see if you can factor the bottom. What multiplies to -6 adds up to -1. It will be x, -3, and +2. All right. There is nothing common to top and bottom, right? We have an x plus 3 on top. If there had been x minus 3, then those two would divide out, and you'd have a whole at x equals 3, but it's x plus 3. So the wholes, none. Vertical asymptote, there are 2. It's at x equals 3 and x equals -2. The two values of x that make the denominator equal to 0. The horizontal asymptote, you only have to look at the non-factored version right here and do the ratio of the highest powers, and it becomes 1 over negative. So this becomes y equals 1 over, or actually be x over -4x squared, which equals -1 over 4x. And as x gets huge, this goes to 0. So horizontal asymptote to y equals 0. The x-intercept is when the top is equal to 0, so x plus 3 equal to 0 means x equals -3. And the domain is all real numbers, except x cannot equal 3 and x cannot equal -2. And there you go. All right, moving on down. Now we're simplifying. So this is addition on number 12. So we're adding fractions. First thing you should do is factor whatever can be factored. Looks like we can pull a 3 out of the bottom on the left here. So that's 3 times 6n plus 5. And then we just have 2n. So our LCD, we're going to find the LCD. You see this? That's going to be part of your LCD, the 3 times 6n plus 5. And then on the other fraction, you have just 2n. And since we don't have a 2 or an n that can go into any of these, we have 2n multiplying. That's your LCD. So putting it together, we got 6n plus 5 as our LCD. So what's, you basically, what's missing here, that's here, or you take this 6n times x 6n plus 5 and divide it by 3 times 6n plus 5, leaves you with 2. All right, 2n. So now we have n plus 6 over the original 3 times 6n plus 5. We are adding a 2n here, so we get the 6n. And since that's not part of the original denominator, we have to do it to the top. Plus 3 over 2n. Now we're missing the 6n plus 5 and another 3, right? We're missing this 3 and this. So we're missing 3, 6n plus 5. Plus 5. Okay. Notice I'm doing to the top and bottom. Now the bottoms are all over the same denominator. Remembering that you are multiplying all of these things, right? The whole n plus 6 by 2n. You can start distributing and simplifying. So this equals 2n squared plus 12n. Now 3 times 3 is 9. So this is 9 times 6n plus 5. So 9 times 6n is 54n, and 9 times 5 is 45. All right, on top and on bottom, we just have the LCD of 6n times 6n plus 5. I'm not bothering multiplying that together. Combining like terms, on top, we have a 2n squared, 12n, plus 54n is 66n, plus 66n, and then plus 45, all over 6n times 6n plus 5. Now, you could try to factor the top, but I'm pretty sure it can't be factored, so that would be the answer. All right, if you could factor the top and break it down, you could maybe reduce this ratio of polynomials so you'd have common factors on top and bottom and divide them out. But I don't think that's possible on this, so we're not going to do it. So that was adding those two fractions together. Kind of an ugly answer. The procedure is pretty straightforward. Now we're going to subtract, like on number 15. So it really is easy when you have these kind. You just take this denominator and multiply it by that up there and so forth. Or you can think of this as LCD is simply m minus 1 times 6, or m plus 2. And so we now would write this as 5m over m minus 1. And then we're going to have to add the m plus 2 on bottom. So we have to do it to the top. Now we have the LCD. And then we're going to be minusing 3m minus 3. If you look, you have m plus 2, m plus 2. The only thing missing is m minus 1. So we're going to go ahead and add that to the top. All over m minus, I'm sorry, that should be m plus 2 if I want to be consistent with what I've decided as far as color schemes. And then we have to add the m minus 1, and we have this. Now the bottoms are the same. Simplify the top, distribute the 5m. That would be 5m squared, because it's 5m times m. And then 5m times 2 is 10m. Now, minus, okay, we have to FOIL this, right? 3m times m is 3m squared, minus 3m minus 3m, which is minus 6m, plus 3. So we're minusing all of this. So if I write this correctly, the product of 3m minus 3 and m minus 1 would be 3m squared minus 3m minus 3m minus 6m. Minus 3 times negative 1 is positive 3. And we have this. This is a little bit crazy. You're going to have to be consistent and write everything out. Remembering that when we subtract, we're adding the opposite, and also that our denominator is m plus 2, m minus 1. We have 5m squared minus 3m squared. So that's going to be 5m squared minus 3m squared is 2m squared. I took care of those two. 10m minus a negative 6m, 10m plus 6m is plus 16m. And negative 0 minus 3 is negative 3, all over the LCD the LCD of n plus 2, n minus 1. And then you would sit there and look to see, can you find two numbers that multiply to -6 but add up to 16? No. Can't do it, so you can't factor. You can't reduce it easily. And there you go. That was the subtraction problem. All right. I also gave you the multiplication problem. 17 and 19, both kind of ugly. And then 21, because it's a division problem. Okay, so looking at this, notice when we're multiplying, you want to factor everything that can be factored. That's the key step. So looking at the top here, multiplies to -40, adds up to -6. Was that -4? Oh, -10 and 4. On the bottom, that multiplies to -10, adds up to -9, that would be -10 and +1. And for the second one up here, we have what multiplies to 9 adds up to 10. That's 9 and 1. And then what's on bottom here is what multiplies to 4 adds up to 5, and that will be x plus 4, x plus 1. And you see x plus 1 is common to top and bottom. That creates a hole in our graph. Also, x minus 10, top, bottom. That creates another hole. We also have x plus 4, which creates a hole. So you have all these things dividing out, and what we're left with is the answer of x plus 9 over x plus 1 as the answer. Oh, that turned out pretty simple. X plus 9, x plus 1. All right, now, looking at 19, we're multiplying, so we don't have to find a common denominator, but we do factor everything that can be factored. So I notice on the top here, we can factor out a 4 and what just happened? Gosh darn it. Okay, I'll pick up at 19.